In this lesson, we'll be looking at number bases. This is a continuation of the WAEC revision series. In our previous lesson, we looked at fractions, approximation, and ratio and percentages, all of that. So in this lesson, which is the second lesson in the revision series, we'll be looking at number bases. So if you have not taken the previous lesson, I would recommend you go and check it out. I'll leave a link to the lesson in the description of this video. So number basis is a system of counting. I'm not going to go into the details of introduction of number basis here. This is just a revision class, WAEC revision to be precise. So if you have not taken a course on number basis, again, I'll leave a link to a tutorial on number basis, which give more details about number basis generally and how to convert from one base to another. So the focus of this class is revision. So we are going to go into solving question right away. Example 11 here, which is the first example. Again, I'm using New General Mathematics, SS3. There's a revision part that covers all the topics you have done from your junior secondary school mathematics down to senior secondary school, which of course will come out in WAEC. So the revision part in that textbook is arranged according to WAEC syllabus, the current WAEC syllabus, and I am taking that in order, following all the questions there that have to do with WAEC. So let's get into this right away. We have to express 157 in base 10 as an octa number. Octa means base 8. So to convert from base 10 to another base, we divide the base 10 number by the base that we are converting to, repeated division. And at each stage of the division, we write down the remainder, even when the remainder is 0. So converting 157 in base 10 to base 8, we are going to divide 157 by 8 continuously until our divisor is 0. So 157 divided by 8. For this kind of division, I'll do it 2 digits at a time. 15 divided by 8 is 1. Remainder 7. 77 divided by 8. 7 divided by 8 is 9. Remainder 5. So write down the remainder. And 19 divided by 8 is 2. That is 8 times 2, 16. And 19 minus 16 is 3. So the remainder is 3. Then we divide again. 2 divided by 8 is 0. Remainder 2. Note my division is 2 divided by 8, not 8 divided by 2. 2 divided by 8 is 0. It's just like, okay, I have 2 oranges that I want to share among 8 persons. If the people that want to share it are not allowed to tear the oranges with knife, of course the oranges will remain. So 2 divided by 8 is 0, remainder 2. So the number in base 8 is the upward collection of all these remainders, so that 157 in base 10 is equal to 235 in base 8. So that is how to convert from base 10 to another base. Now let's go to the second example, which is example 12. And we are to convert 132 in base 5 to a base 10 number. Notice that I call this number individually. I call it digit by digit because this is not base 10. So we cannot call this 132. This is 132 in base 5. I want to convert it to a number in base 10. There are 2 ways we can convert numbers in other bases to numbers in base 10. One way is to multiply each of the digits by their place values. Another way is what we call repeated multiplication. In this case, I'm going to use the first method. That is multiplying each of these digits by their place value. So 132 in base 5. The place value of 2 is 5 to the power of 0. The place value of 3 is 5 to the power of 1. The place value of 1 is 5 to the power of 2. So expressing each of these digits now as a product of their place value, that will be 1 times 5 to the power of 2 plus 3 times 5 to the power of 1 plus 2 times 5 to the power of 0, which is 1 times 5 to the power of 2 is 5 times 5, which is 25, plus 3 times 5 plus 2 times any number raised to the power of 0 is 1. 1 times 25 is 25, then 3 times 5 is 15, and 2 times 1 is 2. 25 plus 15 is 40, and 40 plus 2 is 42 in base 10. Therefore, 132 in base 5 is 42 in base 10. That is for question number 2. Now we'll move on to example 13. It says given that P is 242 in base 5 and Q is 14 in base 5. Calculate P plus Q, P minus Q, P times Q, and P divided by Q. So for the first one, P plus Q, we are going to add 242 in base 5 to 14 in base 5. Now when performing addition or subtraction or any operation at all in a particular base, we must take into account the base in question. Let me start with base 10 that we are already familiar with. So if I'm adding, let's say 27 plus 14 in base 10, 7 plus 4 here is 11. But since we are performing operation in base 10, there's no way I can write 11 there. So I'm going to write 1. The question is, why do I write 1? Because in 11, there is one bundle of 10, we call it one bundle of 10, remainder 1. So it's that one that will remain, that will write rather. Then that one bundle of 10, we take it to the next column and add it to the next column. 1 plus 2 is 3, then plus 1, 4. The same thing we do in any other base. 2 plus 4 here is 6, but we are doing operation in base 5, so I cannot write 6 here. Within that 6, how many 4 can I get from it? How many 5 rather, since the operation is in base 5? How many 5 can I get from 6? Of course, there's one bundle of 5, then remainder 1. There is that one that remains that I will write. Then that one bundle of 5, we take it to the next column. 1 plus 4 is 5. Then 5 plus 1, 6. Again, I cannot write 6 there. Within that 6, how many 5 can I get? 1, remainder 1. I write the one that remains. Take the one bundle of 5 to the next column. Add it here, that gives me 3. So P plus Q is 311 in base 5. Okay? We'll move on to the second one, B, which is P minus Q. For P minus Q, that would be 242 minus 14. 2 minus 4, that is not possible. So we are going to borrow 1 from here. But whatever we borrow is actually one bundle of 5 we are borrowing. Again, let me use base 10 that we are familiar with. Let's assume I want to subtract 9 from this. Or let me use a big number. Let's say 20 minus 9. 0 minus 9 is not possible. So we borrow 1 from 2 and bring it here. And when we bring it here, we say it is 10. Why is it 10? Is it not 1 we borrow here? 1 plus 0 is supposed to be 1. But when we add it here, we say it is 10. Why? Because it's one bundle of 10 we borrow from there. Whatever we borrow here, since the operation is in base 10, is one bundle of 10. Okay, now let me remove this 0, because some people will think because it is 0 there, so we place a 1 by the side of the 0, which makes it 10. No, that is not the case. So let me use 21 instead of 20. 21 minus 9. Okay, 1 minus 9 is not possible, so we borrow 1 from 2. Then when we bring the 1 here, we say this is 11. Why is it 11? Is it not 1 we borrow from here? 1 plus 1, is it not supposed to be 2? It is 11 because whatever we borrow here, it is a bundle of 10. So that one bundle of 10 plus this makes it 11. So the same thing we are going to do in this base here too. Whatever I borrow from here, yes, it's 1 I am borrowing, but is one bundle of 5. And 5 plus 2 is 7. 7 minus 4 is 3. So here, because I borrow 1 from there, I am left with 3. 3 minus 1 is 2. And then these two, I'll bring it down. So my answer is 2, 2, 3 in base 5. And the third one, which is P times Q, P times Q. So we're going to multiply 242, which is P, by 14, which is Q. 4 times 2 is 8. But since my operation is in base 5, there's no way I can write 8 here. So within that 8, how many 5 can I get? I have one bundle of 5, remainder 3. So that 3 that remains is what I'm going to write. That one bundle of 5, I'm going to take it to the next column. So 4 times 4 is 16, plus the one bundle of 5, that is 17. In that 17, how many 5 can I get? 3. Remainder 2. There is a 2 that I will write, the 2 that remain. Then that 3 bundles of 5, I'll take it to the next column. 4 times 2 is 8, plus this 3 bundle of 5. 8 plus 3 is 11 also. 4 times this is 8. And plus this is 8 plus 3 is 11. Yes, I'm right. So in 11, how many bundles of 5 can I get? 2, remainder 1. So that 1 that remains, I'll write it here first. Then the 2 bundles of 5, I'll write it here, which will give me 2, 1, 2, 3 for the first row. Then for the second row, we multiply again. 1 times 2 is 2. 1 times 4 is 4. 1 times 2 again is 2. Then we add 3, we bring it down. That is 3 plus 0, which is 3. Then 2 plus 2, 4. 1 plus 4 is 5. But my operation is in base 5, so I cannot write 5 here. In 5, how many 5 can I get? One bundle of 5, remainder 0. So the 0 that remains, that is what I'm going to write. This one bundle of 5, I'll take it to the next column. Then that 1 plus this, that is 3. 3 plus this, 5. Again, I'll write 0, then take the 1 bundle to the next side. So our answer is 1, 0, 0, 4, 3 for this operation. Then finally, P divided by Q. For division, the easiest way is to convert all the number to base 10. Then do your division in base 10 before you convert back to the required base. So the required base in this case is base 5. So I'm going to convert each of this number to base 10 and then do my division in base 10. 2, 4, 2, which is P, in base 5, expressing each of these as a product of their place value is 5 to the power of 0, 5 to the power of 1, 5 to the power of 2, which is 2 times 5 to the power of 2 plus 4 times 5 to the power of 1 plus 2 times 5 to the power of 0. That would be 2 times 5 squared is 25 plus 4 times 5 plus 2 times 1 because 5 to the power of 0 is 1. And 2 times 25 is 50 plus 4 times 5 is 20 plus 2 times 1 is 2. Adding up this, that will be 72. Then converting 14, which is Q, by dividing P by Q. 14, Q is 1 4, not 14, since this is base 5. Converting 1 4 to base 10 is 1 4. The place value of 4 is 5 to the power of 0. That of 1 is 5 to the power of 1. So I have 1 times 5 to the power of 1 plus 4 times 5 to the power of 0. 1 times 5 is 5, and 5 to the power of 0 is 1. 1 times 4 is 4, which is 9. 72 divided by 9. Now we divide 72, which is in base 10, by 9, which is also in base 10 now. 72 divided by 9 is 8. I'll converting this base 8 now back to base 5, since the operation is in base 5. So to convert base 10 number to base 5, we divide by 5. 8 divided 5 is 1, remainder 3. Then 1 divided 5 is 0, remainder 1. Therefore, P divided by Q is 1, 3 in base 5. That is that for question 13. Let's move on to 14. For 14, we have to convert 1 to 5 in base 8 to base 2. To convert from base 8 to base 2, you can't convert from another base apart from base 10. You can't convert it to another base directly. So we need to convert this number to base 10 first. Then convert the result in base 10 to base 2. You can't convert directly from base 8 to base 2. So how do we convert base 8 to base 10? I'll use a power expansion. That is 1, 2, 5. The place value of 5 is 8 to the power 0. That of 2 is 8 to the power 1. And this is 8 to the power 2, which is 1 times 8 to the power 2 plus 2 times 8 to the power 1 plus 1 times 8 to the power plus 5 times not 1. It's supposed to be 5. 5 times 8 to the power 0. And that will be 8 to the power 2 is 64. And 1 times 64 is 64. Plus 8 to the power 1 is 8. 8 times 2 is 16. Plus 8 to the power 0 is 1. 1 times 5 is 5. 64 plus 16 is 80. 80 plus 5 is 85. 85 in base 10. It is this 85 in base 10 that will convert to base 2. So, and to do that, when converting base 10 number to another base, you divide by the base that you are converting to. So we are converting to base 2 here. So we're going to divide 82 by 85 rather by 2 repeatedly until we get to 0. And at each stage of the division, we write down the remainder, even when the remainder is 0. So 85 divided by 2, 8 divided 2 is 4, 5 divided 2 is 2, remainder 1. And divide by 2 again, I is 21, remainder 0, divide 2 again, 10, remainder 1, divide by 2 again, 5, remainder 0, by 2 again, 2, remainder 1, and 2 divided 2, 1 remainder 0. Finally, 1 divided 2 is 0, remainder 1. The upward collection of all these remainder give us the number in base 2, and that is 101,001. Therefore, 125 in base 8 is equal to 101,001,001. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 in base 2. Okay, that is that for question 14. Example 14. Let's move on to the next one. Here I have if 2, 5 in base s is equal to 3, 2 in base 5, find x. When the base are not defined or are not known like this, we need to express each of the number in base 10. So if I have 25 in base s, to express this in base 10, the place value of this 5 here, let me rewrite the number here. The place value of 5 is x to the power of 0 rather, since the base is s, and the place value of this 2 is s to the power of 1. Doing the same thing to the left hand side, that is 32, 32 rather, not 32. The place value of 2 is 5 to the power of 0, and the place value of 3 is 5 to the power of 1. Expressing each of the digits as a product of their place value, that will be 2 multiplied by x to the power of 1, which is 3x, plus 5 multiplied by x to the power of 0, equal to the right hand side, that is 3 multiplied by 5 to the power of 1, plus 2 multiplied by 5 to the power of 0. 2 times s is 2x, plus s to the power of 0 is 1. 1 times 5 is 5, equal to 5 to the power of 1 is 5 times 3 is 15, plus 1 to the power, 5 to the power of 0 is 1 rather. 1 times 2 is 2. Excuse me. That means 2x plus 5 is equal to 17. Collecting like terms, 2x equal to 17 minus 5. When plus crosses equality become minus. And that means 2x, 17 minus 5 is 12. X will divide both sides by 2. X therefore is 12 divided by 2, which is 6. So the base of this number is 6. Last question. So subtract 2155 in base 6 from 1002 in base 6. We are subtracting this from this. So let me write 10024 minus 5, I'm writing from back, 1 and 2. Okay, the operation is in base 6. 4 minus 5, that's not possible. I will borrow 1 from here. And since the operation is in base 6, whatever I borrow from here is actually a bundle of 6. And 6 plus 4 is 10. 10 minus 5 is 5. Remember, I borrow 1 from here, so I have only 1 left here. 1 minus 5, that is not possible. I need to borrow from here to this place, which makes this place 6. Borrow from that 6 to this place, which makes this place 6 again. Then borrow from that 6 to this place. I was having 1 here. 6 plus 1 is 7. 7 minus 5 is 2. So this remains 5. 5 minus 1 is 4. This remains 5 also minus 2 is 3. So our answer is 3425 in base 6. And for the second one, we have to subtract 1206 in base 8 from 2310 in base 8. 2310 minus 6, 0, 2, and 1. Subtracting this, let's borrow 1 from here to this place since 0 minus 6, that is not possible. And remember the operation is 8, it's in base 8. So whatever we borrow from here is a bundle of 8. 8 plus 0 is 8. 8 minus 6 is 2. We have borrowed 1 from here, there's nothing left here again. 0 minus 0 is 0. 3 minus 2 is 1. And 2 minus 1 is 1 in base 8. Let's remember to indicate the base. The last one, they subtract 110111 from 111010. Have 111010 minus 111011. 0 minus 1, that is not possible, so we need to borrow to this place, then borrow from this place to this place. Since the operation is in base 2, whatever we borrow is a bundle of 2. So if I borrow 1 from here to this place, it's a bundle of 2. 2 plus 0 is 2. Borrow 1 from that 2 to this place, that is 2 again. 2 minus 2, 2 minus 1, 1. I am left with 1 here. Remember, I borrow 1 from here to this place. And because the operation is in base 2, whatever we borrow is actually a 2 we are borrowing, a bundle of 2. So 2 here, then we borrow from that 2 to this place. So I have 1 left here. 1 minus 1, 0. So because we borrow from here, there's nothing left here. That is 0 there. So I need to borrow all the way from here to this place, which makes this place 2. Borrow from that place to this place, which makes this place 2 again. 2 minus 1 is 1. Here, I borrow from this place to this place, which makes it 2. Then borrow from that 2 to this place, which makes this one 1. 1 minus 0 is 1. Remember, I borrow from here, so I have nothing left here. So I need to borrow from here to this place now. So borrow a bundle of 2 from here to this place. That is 2. 2 minus 1, 1. Again, I have 0 left here because I borrow from there. So I need to borrow this 1 here to this place, which is a bundle of 2. 2 minus 1, 1. There's nothing left here again. So our answer is 11101 in base 2.